going to connect the idea of slope to the equation of a line, to a function rule. You're going to start noticing things that we've sort of looked at before. We're just going to look at it from a different perspective. So today we will discover and use the slope-intercept form of a linear equation. Now what I'm going to do is I'm going to go out to onto an online graphing calculator, and I'm going to graph these three lines that you see here, the red, the blue, and the green. So if you see this equation, I'm going to put it in to technology and let it do the graphing for us. And then I'll come back and we're going to do each one. So I'm going to go out to this graphing calculator. Just let me get right over there. There it is. And notice I've typed y equals 1/2 x plus 1. And this is what the line looks like. So everybody see that that's what the line looks like. So I'm going to go back to what we were just looking at and show you that I just basically took, I basically took a screenshot of that and I put it under this box. Okay, so that's the line we just saw. Is everybody okay with that? Now I'm going to go in and I'm going to type y equals x plus 1 into that graphing calculator. And I will put in a new line, and let's do the y equals x plus 1. And I'm just going to change the color here to green so it matches what we did. So notice I put them on the same coordinate graph, but I'm going to go back and just show you that line separate. Again, I hid it behind here, and there's the green one. I'm going to go now and do y equals 5x plus 1 out onto the graphing calculator. Again, I'm going to put a new line here, y equals 5x plus 1. And I'm going to make sure that has its own color, which was blue. And there you can see the three lines all on the same graph. Let me go back. And again, there they are individually. That's what y equals 1/2 x plus 1 looks like. This was y equals x plus 1. And this equals y equals 5x plus 1. I mean, back a few weeks ago, in order to graph these, we had to make a table and use the fav4, the fav5, and put numbers in and get outputs and plot the points. And notice with technology, all I had to do was type in that equation and I can see the line. Now let me show you what all three look like again. So there they are, all on the same graph. And what I want to know is, if you look back here, it says, how does the coefficient is the number in front of that input variable, the 1/2, this case it's the invisible 1 on the green one, and the 5. How does that affect the graph? So what do they have in common and how do they differ? So what do these three lines all have in common? And what you might notice is that they are all touching this point. They intersect at that point. And if you'll notice on the y-axis, that point is 1. Does everybody see that? It's 0, 1. And I just want you to look here at the 1, look here at the 1, look here at the 1. Isn't that interesting? What is different about all three lines? And what you should be able to say is that the blue line is steeper than the green line, which is steeper than the red line. The blue line should have the biggest slope, and the red line should have the smallest slope. I'm going to go to the blue line, remember this point 1, and I'm going to ride up the blue line, and do you see right here, I'm going to kind of go through the crosshairs. So watch as I count the vertical change. 1, 2, 3, 4, 5, and over 1. 5 over 1, the slope of the blue line is 5. Look over here. Look in front of the x. Let's go to the green line. Start at the 1, and it looks like I've got to go right there. Only up. So rise 1, run 1, and I hit the line. That's a slope of 1. And look in front of the x. It's the invisible 1. Let's go to the red line. And see, I got to go up. See this point right here? So I'm going to rise 1 and run 2 and hit the red line. 1 over 2. Did you notice that the slope is the number in front of the x, and this point where the three lines are meeting on the y-axis, all the same, is the number after? Pretty interesting. Let's go back to that graphing calculator, and let's do these. Notice this time the number in front of the x is all the same, but the number after is different. So let me go out, and I'm going to do those, and I'll put them all in, sort of like I did. Let me just get rid of the ones we had. And let's start here by putting the y equals to x. And I'm going to make that, it was purple. So let me hold that down. I'm going to put the color scheme to come up, and it's not coming up right now. Okay, well, we'll let it be for now. Now let me put number 2 in. That would be y equals 2x minus 3. That one should have been orange. Okay. And then I'm going to put the third one that was on there, which was y equals 2x minus 4. And that one, I'm just going to make it be the colors that were on my scheme there. If I can, sometimes it seems to work and sometimes it doesn't. Oh, there we go. And make it black. So if you take a look at those lines, oh, you know what? This one was supposed to be plus 3, so let me fix that. Okay. So what you should notice is they look like train tracks. Okay, so we're going to talk about that. So the this one right here that I'm tracing that goes through 0, 0 is y equals 2x. This one is y equals 2x plus 3. And this one is y equals 2x minus 4. So let me go back. Y equals 2x. Y equals 2x plus 3. Y equals 2x minus 4. And then if we all put them all in the same, this is kind of what they look like. Okay, so notice that they don't meet this time. But what is the same is this 2. So I'm going to go to this orange line, and I'm going to rise 2 and run 1. Look at the slope. Vertical change is 2 blocks. Horizontal change is 1. The slope is 2. It's up 2 over 1, up 2 over 1. Let's go to the purple line. Start with a point. And if I go up 1 block, up 2, and to the right one, I hit the line. So notice his slope is 2. And if I go to the black line, start at this point, up 2 and over 1, notice that that is also 2. Notice that the number in front of the x represents the slope of the line. Now the numbers after, where can we find the 3? Look right here, guys. Do you see that it crosses the y-axis at 3? Do you see that the purple line crosses the y-axis at 0? I mean, we could have written plus 0 up here, but you don't have to write plus 0, right? And then look down here at negative 4, 2x minus 4. So we've just kind of discovered that it seems like when we write an equation, y equals a number x and then plus a constant, it seems that the number in front of x is the slope of the line, and the number after is the point where the line hits the y-axis. And we're going to give that a name right now. So in football, an interception is when like the quarterback is throwing the ball to the receiver and a defensive player comes in and catches the ball. So we're going to use this word intercept, and I want you to think of that football term. So the y-intercept is going to be a point on the y-axis where the line crosses it. So let me show you in terms of football. Here is a blue line. Let's pretend that the quarterback is down here and his receiver is up here, and he's going to toss the ball. He's going to pass that ball, and then the y-intercept, the y-axis comes in. There's a player running, and boom, right there he picks the ball up. This point on this line is called the y-intercept. The y-axis intercepts that blue line at 3 on the y-axis. Now we're going to have y equals slope in front of the x, and the y-intercept goes after. So if we want to write the equation of this line, we could just put the 3 in for the b. Let me show you another one here. Here is the green line. Quarterback throws the ball. The y-axis comes and picks off the ball at negative 5. This point is called the y-intercept of the green line, and it's going to take that b spot. In your textbook on page 200, they talk about the slope-intercept form of a line. Y equals m slope x plus b y-intercept, the slope-intercept form of a line. So if you see a linear equation, input of x, output of y, and you see y by itself equals a number in front of the x minus 4, the number in front of the x is the slope, and the number after, see that minus 4, is the y-intercept. So when you see an equation, it's really easy in this form to figure out what the slope and the y-intercept is. So let's take a look at page 200. We're going to walk through these three. Right now, y equals mx plus b. M is your slope, b is your y-intercept. You might be saying, this is why did they use b? I have no idea. But they couldn't use y because y is already the output variable. Remember slope, we said they use m for? So they use different letters. But anybody in the world, if you talk about y equals mx plus b, they know that b is the y-intercept. Okay, so right now what you have to do, what is the slope of this line? What is the y-intercept? Can you write that down? Okay, well, the slope is in front of the x. It's called the coefficient of x. It's -5. And the y-intercept is the constant, which is the 3. How about you do this one? What's the slope? What's the y-intercept? The slope is 1/4, and the y-intercept is -6. Okay, finally, what is m and what is b in this equation? Well, this one was a little bit tougher because there isn't a number, but it's the invisible -1. Your slope is -1, and your y-intercept is 5. If you have an equation, y equals a number in front of the x plus that constant after, the coefficient, the number in front, will be the slope of the line, and the constant after will be where the line hits the y-axis. Let's go backwards. Now I'm going to give you the slope and the y-intercept, and I'm going to ask you to write the equation. So you will write y equals, and then you'll stop, and you'll look for the slope number, which is -3, and you'll put that in front of the x. And then you can put plus y equals mx plus, and then you find the y-intercept and you write it after. So y equals -3x plus -4 is a good equation. And if you change this back to -3x minus 4, that is good equation. So there was 2 different ways you could have written this one and gotten 100. Okay, your turn. You are going to write an equation. It is going to have a y, it is going to have an x, it's going to have the 3/4, it's going to have the -3. You're going to write the equation y equals mx plus b for a slope of 3/4 and a y-intercept of -3. So you always start with your output variable, y equals. Your slope comes next, 3/4 in front of your input variable, the x. And then you could say plus the y-intercept, which would be -3. Oh, by the way, that's the same thing as -3. So that's just using the form. So why? What can we do with this? We're going to start talking about a really easy way to graph. And let's just start by doing that with this problem, and then we'll go back to the equations. Graph a line with a slope of 2 and a y-intercept of -6. No tables, no calculator. You're going to start by graphing the y-intercept. So we're going to grab your pencil, and you're going to come over, and you're going to go to the y-axis and find -6 and put a point. That is a point on the line. The next thing you're going to do is use your slope to move. Remember that this slope of 2 is 2 over 1. The top number, 2, is going to be your rise, and the bottom number, 1, I'm going to put this over 1. So let me write that in for you so that maybe you won't. So I'm just going to put a little line here. So there's my fraction line. I'm trying to do this with the mouse, guys. And then I'm going to put it over 1. So my slope is 2 over 1. So now what I'm going to do is I'm going to come and I'm going to use the slope to move. So I'm going to start at my y-intercept and I'm going to rise. Whoops, I didn't want to do that. I'm going to rise 2 and run 1. Boom. I'm going to use my slope again. I'm going to rise 2 and run 1. 2 up, 1 over. You could keep doing this forever if you wanted. Do you see the line forming? Pick up my ruler, draw the line, put arrows on both ends, and there is the equation of a line that has a y-intercept of -6 and a slope of 2 over 1. That's how easy it is to graph a line when you know what the y-intercept is and the slope. The y-intercept is a point, and the slope is movement, rise over run. Let's try another one. So right now, I'm no longer given the words. So I have to figure out what is the y-intercept and what is the slope. So let's start with our y-intercept. What is the y-intercept? Now I'm hoping you said 3. So go to your y-axis and you would put a point on 3. Now your slope is -1/4. My recommendation is to hook the negative. Put the negative with the top number. Put the negative, make it -1 over 4. So start at your y-intercept, and you're going to use -1 as your rise. Oh, by the way, that means to fall. Now don't put a point, we're not done. So move down 1, and then you would have a +4 for your run. 1, 2, 3, and 4. I'm going to do that again. I'm going to go down 1, I'm going to fall 1. My rise is a -1, and then 1, 2, 3, 4. I'm going to take out my ruler, draw in a line, put in my arrows, and guys, we just learned how to graph this function rule without the fave 4. So you might want to have just a moment of silence for your BFFs. We don't need the fave 4. When we realize that this is the y-intercept and this is the slope, we can graph this, and let me show you the line. We can graph this without even touching our calculator. We plot the y-intercept and we use the slope to move. Back to page 200. So your book, unfortunately, didn't show that, but they do the backwards one. So let's talk about it backwards here on page 200. They're going to give you the line, and they are going to ask you to write the equation now. To write the equation, you need the y-intercept and you need the slope. Once you have those two numbers, we already wrote the equation a few slides ago. So we know it's going to be y equals, we need the slope. So if we go to 2 points in the crosshairs, remember block counting, you're going to go down in the elevator 1 and run 2. Down 1 is your rise, -1, over 1, 2. Your slope is -1/2, and that'll go in front of the x. The y-intercept's easy. Where does the line hit the y-axis? Well, here's the origin, 1, 2, 3, 4. And this line has an equation, y equals -1/2 x plus 4. Okay, you're going to do page 200, part D. You're going to write an equation by starting y equals. You're going to put the slope in front of the x, figure out what the slope is, and the y-intercept after. Okay, try it. All right, y equals, now what is the slope? So see these 2 points? I'm going to get in my leftmost point, and I'm going to rise. 1, not there yet, 2, 3, 4, 5. I'm at the right height, so my rise is a 5. What's my run? 1, 2, 3. So 5 over 3 is my slope, and it goes in front of the x. What's the y-intercept? Boom, right there. -2. And there's the equation of my line. Okay, so I'm going to give you a chance to just practice a little more. So the video is going to stop, and you are going to write the equation, but I'm stepping you through. Find the y-intercept, find the slope, write the equation. Go ahead and do number 1. Okay, what's the y-intercept? 5, that's easy. Now the slope, I need points in order to be able to find them. So that's 1. Now crosshairs, boom. There's another one up there. There's a whole bunch. But I'm going to rise 1 and run 2. 1 over 2 is my slope. Once I have those two, I don't need, my BFFs, my fave 4 or anything. Y equals mx plus b. Y equals 1/2 plus 5. Okay, do number 2. What's the y-intercept? Boom, -3. Just go over to the y-axis. Where does that line cross? That's the y-intercept. Okay, now slope. I need 2 points in the crosshairs. 1, oh, I got a bunch here. Look at that, right? Okay, slope. I'm going to go down 1 and run 1. Down 1, run 1. The slope is -1 over 1 or -1. Y equals mx plus b. Hey, Mrs. Woodruff, where'd the 1 go? If you wrote y equals -1, x minus 3, you are good. Okay, so that's what we did today. We learned that there's something called the slope-intercept form of a line. We learned that the number in front of the x is the slope, and the constant after is the y-intercept. When we are plotting a line, we can just plot that y-intercept and use the slope, rise 1, run 2, rise 1, run 2 to graph the line, or do the backwards to get the equation. When you come into class, we're going to practice all of this, and then we will head to some individual practice. Guys, I hope you have a great day. It's all about slope-intercept form of a line.